Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 7, Lesson 3 on box plots. Now, the entire unit I want to keep coming back to this idea of a statistical question, right? A question that can't be answered with just a single number or anything like that, right? One that has a variety of different ways it can be answered. Like for instance, one of my favorite examples, how much money do lawyers make? Right? If you want to answer that question, it's tricky, because you could talk about the minimum amount, the maximum amount, the median amount. Last lesson we learned about the quartiles, so you could talk about like the first quartile salary, the third quartile salary, the range of salaries, the interquartile range of salaries. Plus, we could also look though at pictures, right? And those are plots. Those are things like dot plots. Histograms, you might also know those as bar charts, right? And pictures of data. I go out and I like to survey 100 lawyers and ask them what their salary is. Pictures of data then can really help us because we can look at them and go, oh, from this picture of the data set, I can tell, well, most lawyers make around, $90,000 a year or something like that. A box plot is another graphical display of a data set. So let's get into them right away, learn how to read them, learn how to construct them, etc. Here we go. A box plot is a graphical display of a data set that shows how its minimum, maximum, first quartile, third quartile, and median values are spread out along the range of the data set. So that's it. When you're looking at a box plot, what you can really figure out about it are the minimum value, the maximum value, the median value, and then the quartiles. Literally how this data set is being broken up into quarters. So let's look at a box plot, not a blocks plot, a box plot in exercise number 1. A study was done on how fast students could type after taking a keyboarding class. The students in the class were measured to see how many words per minute they could type. The results are shown in the box plot below. Based on the diagram, state the minimum, maximum, first quartile, third quartile, and median number of words per minute typed. This is known as the 5-number summary. All right, so this is really cool. It's really easy to read a box plot, all right? So here's how it goes. Not surprisingly, this mark, right, shows us the minimum value. So let's mark that up on our box plot. The minimum value, and that happens to be not 9, because these are going by 2s, that happens to be 8. So the minimum value is 8. We always have to kind of watch what we've scaled this axis on. Now the maximum, again, not surprisingly, is way out there. So the maximum value is illustrated by where the box plot ends, and that's 38. All right. So the first quartile, the third quartile, and the median. Well, those are all about the box itself, okay? So where the box begins is our first quartile value. Where the box ends is our third quartile value. And the line that's right in the middle of the box is our median value. So our first quartile value is 22. Our third quartile value is 32. And our median value is right there at 28. So it's great, and it really just tells us how these quarters of our data set are spread out. So the first quarter of the data, right, goes from 8 up to 22. It's quite wide, right? That first 25% of the data set is spread out quite a wide range. Then the next quarter of the data, right, the sort of the 25 to 50% is in here. Then the next quarter of the data, the 50% to the 75% is in here. That's where the data is kind of the most crowded, right? Because it's all fitting in this rather small width, and then the final quarter of the data is lying out here. That's kind of how you want to be able to think about box plots. They're very, very simple, right? Both to construct and to read, because they're just showing us these 5 really important numbers. The minimum value of the data set, the maximum value of the data set, the first quartile, also known as the lower quartile, the third quartile, known as the upper quartile, and the median, the one that lies right in the middle. Okay, let's keep going. Here we go, exercise number 2. The heights in inches of 50 7th grade students are shown in the box plot below. What is the interquartile range of this data set? show how you found your answer. All right, well, see if you can figure out the interquartile range based on this box plot and what we just talked about. Pause the video now. All right, let's do it. Well, the interquartile range, as we talked about in the last lesson, sometimes it's abbreviated as the IQR. The interquartile range is always the third quartile value minus the first quartile value. So for us, the first quartile value is the beginning of the box. That's right here, and this is scaled in ones, not two this time. The third quartile value is where the box ends. That's right here, and that's at 64. So that's going to be 64 inches minus 59 inches, so the interquartile range is 5 inches. Right? We could also obviously be asked about what the range is, right? And we would then find the minimum value, which is 52, the maximum value, 68. We would subtract those two, and we'd get 16. All right? So that's it. Really simple. Just an application of being able to read a box plot, knowing that that's the minimum, that's the first quartile, that's the median, that's the third quartile, and that's the maximum. As simple as that. Now, you always want to be able to do two things when you introduce a new display of a data set, right? Again, dot plots, histograms, and now box plots. The two things you want to be able to do is, given one, can you read it? Can you get information from that statistical display? The other one is, of course, can you create the statistical display itself? So let's play around a little bit with that in the next couple exercises. All right, exercise number 3. Students in Mrs. Wright's math class were studying how many text messages kids with cell phones send on a Saturday. They surveyed 18 students and collected the following data. A, find the 5-number summary below, i.e. the min, the max, the median, the first quartile, and the third quartile values. Now again, revisit this for a minute, right? What would have been the statistical question? Maybe the statistical question would have been, how many text messages do kids send on a Saturday? Right? And that's a great example of a statistical question because there is not one set number, right? The minimum number was 2, the maximum number was 29. Actually, let's write those two down. Those are 2 of the 5-number summary, right? So the minimum, that's simple, 2. The maximum, also pretty easy, is 29, right? 29 text messages. I could see it. I've had some of those days. Now, finding, of course, the first quartile, the median, and the third quartile is more challenging. We've done that before, so what I'd like you to do now is pause the video. Remember, we've got 18 total students, so use your analysis to figure out the median first, and then the first quartile and the third quartile. Pause the video now and go ahead and do that. All right, well, we've got a total of 18 students, right? That means that we can divide this data set just in half by having the lower 9 and the upper 9. So where is that? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we've got our lower 9 and our upper 9. Let me just count to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. 9 in each. That 14 is definitely in the lower half. I don't want you to think it isn't. Now, because there's an even number, right, there is no number right in the middle. So to figure out what the median is, right, we're going to find the number that's right between 14 and 16. We really don't have to find the average to do that because obviously the number that's right between 14 and 16 is 15. All right, and that's one of my numbers. All right, and now let's find that first quartile and that third quartile. Now remember, to do that, it's really simple. To find the first quartile, we're going to just ignore all of this. We're only going to look at this. We're going to pretend that that's our data set, right? Now, we want to find the median of that data set. Since there are 9 values, an odd number of values, there will be like one value right in the middle, and there will be 4 below it, and there will be 1, 2, 3, 4 above it, and so our median has to be the 7. Now again, it's not the median of the entire data set, it's the median of the lower half of the data set, so the first quartile value is 7. Same thing for the upper quartile. I'm just going to ignore the lower half of the data set. I'm going to look at the upper 9 values. I want to find the 5th one. 1, 2, 3, 4, 5. That's going to be this first 24. 4 values below, 4 values above, great. So the upper quartile, the third quartile, is 24. Known as the 5-number summary. The minimum, the maximum, the median, and then the median of the lower half and the upper half, the first quartile and third quartile, respectively. Now, how do we create a box plot? Well, it's actually pretty easy, all right? Much, much easier in my mind than creating a histogram, and dot plots are pretty easy to do, you know, but this isn't so hard itself, right? And here's what I do every time. I take each one of these 5 numbers and I'm going to draw a very tiny vertical line above them. Here's what I mean, right? The minimum is at 2, so I'm going to draw a tiny vertical line above 2, right? The maximum is at 29, so I'm going to draw a little tiny vertical line above 29. Then we've got the median at 15, draw a tiny vertical line above that. Q1 is at 7, again, tiny vertical line above that. Q3 at 24, tiny vertical line above that. I'm now going to draw a box between my Q1 and my Q3, and then I'm going to extend these lines away until they hit the max and the min. All right. We used to call these plots box and whisker plots, and then they got rid of the whisker part of it and just called them box plots. The idea is, of course, that this looks like a box, or the best I can do drawing a box, and then these are whiskers that are sort of pointing out from them. Again, not the most lovely box. It looks like more of a snake that got sick or something. I don't know. Anyway. Very, very easy to construct a box plot. As long as we can find our 5-number summary, we just simply mark off all 5 numbers on that number line, create the box between the first and the third quartile with the median somewhere in between them, and then extend those lines, those whiskers, out to the maximum and the minimum. All right, let's play around with another box and whiskers plot that's a bit more challenging. All right. The most challenging type of box plot to make occurs when we're given an unlabeled number line. In other words, last time you had to find the 5-number summary, and then I gave you this beautiful number line that had all these numbers labeled on it, etc., and you just had to plot them. Worst case scenario is that you're given a completely unlabeled number line. So you have to figure out, should this number line go by 1s, should it go by 2s, etc., etc. And we'll get to that question in a moment. But the first thing I'd like to take a look at is finding the 5-number summary. So let's take a look at exercise number 4. A sample of 20 people at the pool were asked their ages, which are shown below. Letter A, find the 5-number summary, label each number. All right, well this time I'd like you to do it all on your own. Don't do letter B, we'll revisit that in a moment, but I'd like you to find the 5-number summary for this data set. All right, well let's tackle the easy ones first. The minimum 4 and the maximum 52. So here we go. Those are 2 of our 5 numbers. So the minimum is equal to 4. The maximum is equal to 52. All right, so now for the harder part, right? We've got a sample of 20 people. That's nicely divisible by 2, so we're going to have a lower 10 and we're going to have an upper 10. Let's find that place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. All right. So in other words, our median should be the average of 15 and 19, or the number that lies in the middle of the two. Again, if you need to, you can always find that by averaging those 2 numbers. And if you can figure it out just by thinking about it, that's great too. So anyway, the median here is 17. Now let's find those lower quartile and upper quartile values by thinking about the lower half of the data set and the upper half of the data set respectively. So the lower half has 10 values. Again, an even number, which is a little bit annoying, but at least I can look at those 10 and go, well, there's got to be 5 and 5, right? So I've got 1, 2, 3, 4, 5, which means there's going to be Q1. And let me do it for the upper half as well. 1, 2, 3, 4, 5, and that is going to be Q3. All right, so we're going to have to do some averages again, although we shouldn't have to do any average to figure out Q1. If the 2 numbers on either side of Q1 are 9, then the first quartile is 9. All right, so Q1 is 9, and Q3 is going to be the average of 38 and 40, or the number that's immediately between them. and that's 39. All right, so we got our first quartile, our third quartile, our median, our min, and our max. All right, and again, this is no different than the last problem until we reach letter B, okay? So how do we deal with something like this? Well, number one, it's my ardent hope you don't have to. Okay, most statistical plots these days are created on statistical programs like Microsoft Excel or Google Sheets, or I'm sure there's something for the Macintosh. You know, there are all sorts of programs that you can use to create statistical plots, including box plots. But sometimes we still have to do them by hand. So how do we know what to scale this number line by? Well, here's what we have to do. We first need to count out how many spaces are along this number line. So literally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. I think there's actually 30. I think I missed one in there. There are 30 spaces, right? 30 spaces along this number line. Not 30 dash marks, but actually 30 like 1, 2, 3, 4. 30 spaces. Now here's why I like to know that number. I then look at the range. What's the range? 4 to 52. So the range is going to be 52 minus 4, which is going to be 48. All right. Now, why are these two numbers so important, the range and how many spaces there are? Well, if the range was smaller than the number of spaces, let's say that the range was 25, not 48, well, then I could just make all these go by ones because there would be enough to fit the entire range in. But with only 30 spaces, I've got to fit in 48. That's not going to work. So I can't scale my number line by ones. So here's the advice I always give to kids. If you can't scale a number line by ones, scale by twos. If you can't scale by twos because they're too small, scale by fives. Not threes, not fours. The human mind doesn't really think well in threes, multiples of threes, multiples of fours. Trust me, try it. Try to like rattle off a bunch of multiples of 3. You know, 3, 6, 9, 12, 15. You have to start thinking about them. On the other hand, multiples of 2, that's easy. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, right? Multiples of 5, also easy. 5, 10, 15, 20, 25, 30, 35, 40. So if you can scale by ones, do it. If you can't, scale by twos. If that's not enough, scale by fives. If that's not enough, scale by tens. If that's not enough, scale by 20s or 25s, then maybe 50s, then 100s, etc. Right? Now, we've got 30 spaces. If I scaled each one of these by twos, I could fit a range of 60 in here. 60. I only have a range of 48, so scaling by twos will get the job done. So literally, I will now, right, put a 0 here, 2, 4, 6, 8, 10, 2, 4, 6, 8, 20, 2, 4, 6, 8, 30, 2, 4, 6, 8, 40, 2, 4, 6, 8, 50, 2, 4, 6, 8, 60, and maybe get a little 0 there to make it 50 instead of 5. And everything's now going to fit, right? Now I can put my minimum down at 4. Be careful, it's going to be right there. My maximum at 52. It's going to be right there, right? My median is at 17. I got to be a little careful on this one because that's going to be halfway between 2 marks. My first quartile at 9, same deal. It's going to be halfway between the 8 and the 10. And my third quartile at 39, again, halfway between the 38 and the 40. But now I can draw my box. And I can extend those whiskers out to the max and the min. By the way, notice, right, notice how kind of crunched up this lower quarter of the data would be, and then even the next quarter, and then how spread out this quarter is, right? There is a huge spread between the median and the third quartile, and also a pretty big spread between the third quartile and the maximum. This lower half of the data is really crunched in because there's so many younger kids at the pool, right? Right? The vast majority of people at the pool, well, not the vast majority, but half the kids at the pool are 15 and less years in age, right? And yet, the highest age is 52, right? So like there's a lot of crowding down here in the data set, and the data up here is really spread out, which is what this kind of box plot can tell us. All right, let's wrap this thing up. A box plot, like a dot plot and a histogram, is just another graphical display of a data set. Now, unlike a dot plot, which shows you every data point, and a histogram, which doesn't show you every data point, but it shows you how many data points fall in certain categories, right? A box plot really serves to show you how the data is spread out amongst its minimum, its maximum, and then the values that cut it up into quarters, i.e. the lowest quartile, the highest quartile, and the median, right? You'll be able to then look at a data set and really kind of figure out how the data is spread out. We're going to start using box plots in the next 2 lessons to actually make some determinations about the way a data set is spread out amongst its range of values. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.